This one is asking us to find the first partial derivative for x, y, and z. So remember, when we do that, we take the derivative of the variable, we hold all the other variables as if they are constants. So this one is involving an exponential, and so you'll need to remember from, again, we didn't teach it in this class, it's from 210, but the derivative of e to, let's go ahead and use u. If we take that derivative, e is its own derivative, so that's e to the u, but then the chain rule says then we need to take the derivative of u itself. U is some kind of function, not just x. Okay, so we're going to do that. You also see a potential for a chain rule here, or sorry, a product rule. So remember, for product rule, it turns out in this case, because e doesn't have an x in here, if there was an x up here, we'd have to use the product rule, but this is when we're taking the derivative of x, e is just a constant, e to this, because the exponents. Okay, but if you need to use the product rule, remember, you take the derivative of the first function times the second function unchanged, just sort of copy it over there, plus the first function unchanged times the derivative of the second. Okay, so let's find the partial derivative with respect to x, and then we can plug in these points. So I'm just going to do it in general. Partial derivative of this function with respect to x, I take the derivative of x, that is 1, right? Derivative of x is 1. E to the 2y 3z, these are all constants. This is all a constant, so it tags along for the ride. And then sort of just to finish this off, I take this derivative at this point 1, negative 1, 1, and so I get e to the 2 minus 1 plus 3 times 1. So that's going to give me negative 2 here, right? 2 times negative 1 and positive 3. Negative 2 plus 3 is just 1, e to the 1 power, or just e. I'm going to put the 1 power just to remind us that it's an exponential, but that's, you could just enter it as e to the e, right? So let's do it with respect to y, and when we're taking the derivative with respect to y, x is a constant, it's being multiplied times e, so it just tags along for the ride. We don't take its derivative, it's a constant, as if, you know, if it was like the number 2, we just write it down. E is its own derivative, so we get e to the 2y plus 3z. Nothing happened here, so we did take its derivative, so, but that's this part here, right? And then now we need to use the chain rule, so we take the derivative of the exponent. Derivative of 2y, derivative of y is 1, 1 times 2 is 2. And then derivative of 3z, z is a constant, so that's 0. So our answer for the partial with respect to y, 2x e to the 2y plus 3z. We can plug in our point that we're given, 1, negative 1, 1. So you get 2 times 1 e to the 2 times negative 1 plus 3 to the positive 1, 2 times 1, so we get 2, negative 2 plus 3 e. And you're going to see the same thing's going to happen with the derivative partial of z, right? We're going to get the same thing. X is a constant, so it tags along for the ride. We get e to the 2y plus 3z, that's the derivative of the outside. And then now, using the chain rule, we need to take the derivative of the exponent. Derivative of 2y is 0 because y is a constant. Derivative of z is 1, so that's 1 times 3. derivative of 3z is 3. So that gives us f of z equals 3x e to the 2y plus 3z, and we can plug in the point. That gives us 3 times 1 e to the 2 times negative 1 plus 3 times positive 1. So that's going to give us 3 e to the 1, or just 3e. So those are our 3 answers for those. First derivative. So be able to do that kind of equation, and then just, derivative with e.